I'm Anil Kumar. Welcome to my series on vector addition. We are going to discuss the geometric approach to add vectors in this particular video. We'll talk about sum of two vectors, difference of two vectors, head to tail triangular method, parallelogram law for adding vectors, and also subtracting vectors. We'll see how to add parallel vectors and work with three or more vectors. We'll take up three applications which will ensure that you have once understood all these concepts. One will be based on a ship being towed by two tugboats. Then we'll take up one where we'll find difference of two unit vectors with an angle of 150 degrees between them and ground velocity of a plane, where plane velocity and wind velocity is given. So when I say geometric approach, I mean we'll be most of the time sketching our vectors with showing their magnitude with length, direction with arrow. So if I have two vectors kind of like this, we will see how to add or subtract them, right? So that's the key idea of this particular video. Now these vectors could be in different directions. They could be parallel also. So we could also have vectors kind of like this. That means they are collinear, right? Maybe in opposite direction. So any combination. And we could also have more than one vector. So we could have, let's say, three vectors. So how to deal with three vectors? That is also part of this particular video. And we'll actually take real life situations to understand. Since, vectors basically help us understand all these physical identities and operations better. So let's first understand sum of two vectors. Now, when we are talking about sum of two vectors, let's take few scenarios. So let's say force is being applied to an object. So let me take three different scenarios. Okay. So in first case, let us say we are applying force. Two forces are being applied. Let's say these are the two forces being applied. So they are in the same direction. In the second case, we could have a force which is being applied here, which is a push, right? And the other one could be a pull, right? In the third case, we could have a force which is being applied in different directions, kind of like this, right? So in all these cases, what we really find is that in the first case, if we have a force F1 and F2, then the net result which moves it is basically F1 plus F2, right? In this case also, since they are acting in the same direction, if we have a force of F1 and a force of F2, then the net result is indeed F1 plus F2. Right? Because they are in the same direction, so their magnitudes get added up. Right? Now, in this case, however, they are at an angle. So let's say this is my force F1, this is the force F2. In that case, we will find that the magnitude of F1 plus F2, we are saying the magnitude, okay? So what we see in the first two cases is that the magnitude of F1 plus F2 is equals to magnitude of F1 plus magnitude of F2. Here also, we find that the magnitude of these two forces is same as the sum of these forces. But when they are being applied at an angle theta, in that case, the sum of these two forces is less than the sum of individual forces. Is less than individual forces, right? So that is normally the case. If they are in the same direction, then they become equal. That's kind of important to understand, right? Now, you can actually get a net result of 0 also if you have a case here where the forces are being applied in this fashion, that some force is applied and equal amount of force is applied in the other direction. That is to say, if one force is F1, then the other force is in the same direction, right? But we call it F2, right? So the other force is F2, which is in the opposite direction, but the same magnitude. So in this case, if the magnitude of F1 is equals to the magnitude of F2, in that case, F1 plus F2 is equal to 0. Correct. Now, in this exercise, if I'm writing capital letters, we'll treat them as vectors. Otherwise, in most of the cases, when I write lowercase, then I'll put a line on the top. So these forces are vectors. So where Fi is vector for us, right? So assume that Fi is vector. And when I write like this, the absolute value, that means magnitude. Of Fi. Is it okay? So I'm not putting a bar on top or trying to make them bold, but try to understand that these are being represented as vectors. So when you add vectors, these are the different scenarios which can happen. So we'll take up examples to understand how to add them actually with some values. But I hope the concept is clear. What happens when you add two vectors? Now similarly, now let's talk about difference of two vectors. So difference is adding, let's take an example. Let us say that one of the vectors is in this direction. The other vector is kind of like this. So let me write these vectors as A. So now I'm writing a line over that using lowercase. Is it okay? So that means a vector for us. So now, if these are the two vectors, and if I have to find the difference, that is to say, I have to do what is A minus B equals to. So that becomes the difference. Then how can I do it? So the idea is, first, A vector will be like this only. So we can draw the vector A. Any vector parallel to A will be kind of like this and same length. So the length is same. So we'll call this as our vector A. Minus B really means that the direction is reversed. So minus B really means that the direction is reversed. So if this is B, then minus B will be what? Let me draw it here first. So same magnitude, parallel vector, that becomes minus B. So A minus B basically is also addition of two vectors. The other one is negative. Is that okay? Negative means reverse direction. So the other one becomes kind of like this. So starting from this position, that is A, this is minus B, ending there will result into the vector C, which represents A minus B. Is that clear to you? Right. So that is the difference of vectors. So we kind of made a triangle to show this particular situation. Now let me take another example where I will use a parallelogram. So let us say that we have two vectors acting at a point. Let's say this is the point. Two forces are acting here, right? Let's say we have a force in this direction, which let me call as F1, and we have a force in this direction, which is, let us say, F2. Now, if I have to do F1 minus F2, the idea is to do F1 minus F2, the difference. How do I do it? Now, one way is that this force is F1. I can from this point draw force F2 like this in opposite direction. Do you see that? So what really happens is that starting from here, in this direction we have F1 and this one is minus F2. And therefore this resultant here gives me F1 minus F2. Is that clear? So that's one way of looking at it. The other way is that we can actually complete a parallelogram here. Drawing a force which is parallel to F2, and from here drawing the force F1 parallel to F1. Since we want to do F1 minus F2, we could also go from this position. From here, if I say this is F1, right? This is F1 in this direction. Now F2 is in that direction. So F1 minus F2 will be this. That is minus F2. So what you see here is that the diagonal of the parallelogram represents this diagonal. The shorter one in this case, the difference of F1 and F2. You get an idea. Correct? So if I have a parallelogram, let's now again look into a situation, right? So I'm just now making third diagram for you. In this diagonal, there are two diagonals, right? So for this parallelogram, we have two diagonals. If this is a vector in this direction is, let's say, P, and the other vector is Q in this direction. In that case, diagonal shown in green is P plus Q. Do you see that? So P and Q, they added up to give you this longer direction, diagonal, which is P plus Q. The shorter one is P minus Q. So if you look into this diagonal, that is P minus Q. Do you see that? So if you complete a parallelogram, then one diagonal represents addition of two vectors, the other one represents subtraction of two vectors. Perfect? So in general, if I have a vector which is a tail and then the head, then the vector which points to the head, take away the tail, gives you the difference. Is that clear? So we'll take a few examples which will make this point absolutely clear, but I hope here you understand the result of adding and subtracting two vectors, right? We basically have two techniques which I touched upon in earlier example. One is called head-to-tail triangular method to add or subtract vectors. Now I'll do a question here to illustrate how to use head-to-tail method, triangular method, to add or subtract vectors. So the question here is, given vector A and B such that the angle between them is 50 degrees, A is magnitude 2, B is magnitude 3, determine A plus B. Okay. So A is magnitude 2. So let us say this is my scale 1, right? So magnitude 2 means this much. B is magnitude 3. Angle between them is 50 degrees. So we say 1, 2, 3. Correct? So that is B. This is A. angle between them is given to us as 50 degrees. So this is the angle 50 degrees between them. Now, if I have to add them, then in that case, we need to put the vectors head to tail. So starting from this position, let's say this is the vector A. Let's say this point is O and this point is capital A, right? And then what we do here is that we sketch this vector or translate the vector B so that its tail is on the head of this vector, right? So we draw a parallel vector here. So what we do here is we translate the vector B so that the tail of B is on the head of A. So that is the name, head to tail, right? So the head of A is to the tail of B, and that gives you the sum. So the sum will be from the starting point to the ending point. So that becomes the sum A plus B. You can see that. Now to find the resultant in a question like this, how should we proceed? Well, we are given that this angle between them is 50 degrees. That is to say, since these two are parallel, right? These two are parallel. It makes 50 degrees right there. So the angle between the two vectors will indeed be, when you add them, this angle will be 180 minus, let me write, 180 degrees minus 50 degrees, which is 130 degrees, correct? So this angle will be 130 degrees. And now, to find the resultant, we can use cosine law. To find the resultant magnitude, correct? So from the cosine law, we can say that the magnitude of vector A plus B is equal to magnitude of A square plus magnitude of B square minus twice magnitude of A, magnitude of B times cos of the angle between them, which is 130 degrees. Do you see that? So let me write this as square root of all this. So that is what you get as the magnitude, right? In our case, we are given that the magnitude of A is 2, so we get 2 square plus 3 square minus 2 times 3 times cos of 130 degrees. So we can actually find this answer and find the magnitude, correct? So we have 4 plus 9 minus 4 times 3, 12 cos of 130 degrees. 4 plus 9 minus 12 cos of 130 degrees is equal to 4.55, right? So that becomes the magnitude in this particular case. We know the magnitude now. In vectors, you have to find direction also. So the direction will be now given with respect to, let's say, A. So let's say this is the angle theta, which resultant A plus B makes with A. So we can find this angle using sine law. So we applied cosine law to find the magnitude. So here we found magnitude, right? And now we are going to apply the sine law. We know we want to find this angle theta. We know B magnitude is 3. Okay. So in that case, sine theta over 3 is equal to A plus B is 4.55. So sine of 130 degrees over 4.55. Is it okay? So that is how you can find. So sine theta is equals to 3 over 4.55 sine of 130 degrees, right? Which is, so 3 times sine of 130 degrees divided by 4.55 is equal to 0.50508, and therefore theta is equal to, we can write theta equals to sine inverse of 0.50508, which is, we do sine inverse of our answer, which is equal to 30.33 degrees. Okay? So we get our answer as 30.33 degrees. So we can say that vector A plus vector B is equal to 4.55 at an angle of 30.33 degrees with vector A. Do you see that? So we can give this direction with respect to one of the vectors. So algebraically, if you have to find the sum, that is how you do it. And to sketch, you could adopt this method of head to tail and make a triangle, right? You could have made a parallelogram also, which we'll see in the next part. So now we'll understand parallelogram law for adding vectors. Question is, given unit vectors A and B such that the angle between them is 60 degrees, determine magnitude of A plus B. So what we are given here is vector A. When we say unit vector, it means magnitude is 1, okay? And the angle between them is, so let's put it like this. So each is 1 unit long. The angle between them is 60 degrees. You can find the sum by forming a parallelogram and see how. So the idea is we will place the other vector, which is B. Let me write down A and B first, right? So we have vector A here and vector B on this side. So we can actually translate vector B so that we put its tail on the head of A, kind of like this. Is it okay? As you can see, joining this point gives you a parallelogram. That is why it is called parallelogram law for adding vectors. Now here the diagonal represents the sum of these two vectors. Perfect. As we saw in the last case, you realize that the angle here, outside angle is 60 degrees, which is given to us, exterior angle. But the angle inside is 180 degrees minus 60 degrees, right? Which is 120 degrees. Do you see that? So this angle is 120 degrees for us. So now you can apply the cosine law to find the magnitude of A plus B. Do you see that? Okay. Now, so let's apply the cosine law to find magnitude of A plus B. So the magnitude of vector A plus B will be equal to magnitude of A square plus magnitude of B square minus 2 times magnitude of A times magnitude of B times cos of angle between them. So let's call this angle as phi, which is 120 in our case, right? So, and then square root. This is square without square, right? That is the cosine law, right? So in our case, we are given unit vector. So unit vector means magnitude is 1. So we'll write 1 square plus 1 square minus 2 times 1 times 1 times cos of 120 degrees square root. So now we can use the calculator to find the magnitude. So it is 1 plus 1 minus 2 cos of 120 degrees. We'll square root this number, which is 3 for us. So square root answer equals to square root 3. So square root 3 is the answer. Always magnitude is going to be positive, right? So the magnitude of sum is square root 3. Good. So we can always apply cosine law to find magnitude, and this parallelogram gives you the result. You will now notice here, if the angle given to us is, for example, theta, then in the formula phi is 180 degrees minus theta. That is important to understand. And you should also know that cos of 180 degrees minus theta is minus cos theta. So we are going to use this formula in one of our applications. Okay, let's move on. We considered two vectors so far. Let us take example with three vectors. Now this, all what we have learned can be applied to any number of vectors. So given vectors A, B and C, construct vectors equivalent to their sum, A plus B plus C. Now these are the vectors given to us. So if I have to form sum of A, B and C, we will adopt the method of placing head to tail. Correct? So let's begin with vector A. So vector A is this one, right? So we'll begin with vector A. So I have to construct a vector which is in the same direction and of same length. So that is my vector A. Correct? Now vector B is kind of horizontal. We'll place this vector, the tail on the head. That becomes vector B. And now at the head of B, we can put tail of C, and then we'll sketch this vector and draw it from here. The resultant is from starting point to terminating point. So that gives you A plus B plus C. Is that clear? Perfect. Now in the next example, we have to do minus C. Now what is the meaning of minus C? Minus C basically means that the direction is reversed, right? That is what it means. So we are given C just parallel to this, but opposite in direction. That will be minus C to us. Correct? So let me redo the whole thing with minus C this time. So we'll again go with vector A. Let's say this, right? So we say vector A, parallel and same length. Vector B, which is here. And this time the vector C will be in that direction, right? So the net result will be from starting point to the terminating point. That will be A plus B minus C. Is that clear? So whenever we are adding negative vectors, we actually reverse the direction to get negative vector. Perfect. So that is how it is to be done. So I hope that point is well taken care of. Now we have application questions based on our learning. The question here is, an airplane heads due south at a speed of 400 kilometers per hour and meets a wind from west at 100 kilometers per hour. What is the resultant velocity of the airplane? Now, whenever you're working on such questions is good to sketch on a coordinate plane. We are given airplane heading south at a speed of 400 kilometers per hour. So what we can do here is, and this wind is from west, that means from this direction. So let us say that this length here represents the airplane heading south. Now in this case, what we have done here is that this length represents 400. This length, which is shown here, is 400. So 100 kilometers per hour will be 1/4 of this, correct? Kind of this much. Okay. Which is wind from the west. So wind from the west is from this side. We have to place the tail on the head to get the sum. So that becomes the wind from the west. Do you get an idea? So basically we started with two vectors. One, we are saying that this is the plane south and this is the wind from the west. When we have to add them, we place them so that the tail is on the head of the first one, right? So that is how you get it. And now the resultant will be from starting point to the end point. So that is how you have to sketch your diagram. Let's say these points are A, B, and C. Since the direction is north, south, and east, west, we do have a right angle here. And the length BC will be represented as 100 units in the diagram, right? So what is the resultant? So the resultant is AC. Now in this case, you can find AC by using Pythagorean theorem. So you can say the magnitude of AC is equal to 400 square plus 100 square square root. Right? So this is your magnitude. So which is square root of 400 square plus 100 square, which is equals to 412, let's say 0.3. Okay. So that is the magnitude. The units will be kilometers per hour. Whenever we talk about vectors, you have to look into direction also. So the angle theta, let's say we call this angle theta now for the time being, we can find that tan theta is equal to 100 over 400 or 1 over 4. So theta is equals to tan inverse of 1 over 4. Right? Let's find this angle also. So we got shift tan inverse of 1 divided by 4, bracket close, equals to 14.03. Let's write this as 14 degrees. So from the vertical it makes 14 degrees. Now in vectors, this angle could be given in different ways. We prefer to write bearing angle. Bearing angle is always measured from north, so we have to give that angle. We know this is 14 degrees, right? So how much is that? So bearing angle is 180 degrees minus 14 degrees. Correct? So let's do it. 180 minus 14 equals to 166. So we have 166 degrees from north. So we say 166 degree bearing. Whenever you write bearing, they are clockwise from north. Correct? So now we can write down the resultant velocity as our answer. Is 412.3 kilometers per hour at bearing of 166 degrees. Do you see that? So that becomes the solution for the given question. So I hope all the steps are absolutely clear. Okay. So let's take the next example now. A ship is being towed by two tugboats. If F1 and F2 is the force exerted by the two tugboats at an angle of theta, then show that F1 plus F2 is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta. So let us say that we have a ship here. Okay. Let's say this is a ship and it is being tugged by two tugboats. Let's say one is at an angle of theta to the other. So let me take the other one horizontal. It helps. Let us say these forces are F1 and F2. So whenever I write capital letters, these are vectors, okay? They have magnitude and direction. We are given that the angle between them is theta. Now we have to find the resultant F1 plus F2. So from our learnings, we could use either of the two things which we learned. One, we used triangular law, right? And one parallelogram, right? So we could use our triangle or parallelogram. Either one of those methods can give us the answer. Now, if I use, let us say, the parallelogram, for example, in that case, I will sketch this here and complete my parallelogram. Then the resultant will be this, correct? So that is F1 plus F2. Perfect. If I am considering a triangle, then I am considering only these two sides, F1 and F2. Right? Now, here the angle is theta. What is the angle inside? The inside angle is 180 degrees minus theta. Perfect. So both triangle and parallelogram actually gives you the same figure. Do you see that? That's important to understand. Now, in this situation, we are going to apply cosine law. So from cosine law, we know F1 plus F2 is basically equal to square root of magnitude of F1 square plus magnitude of F2 square minus 2 times magnitude of F1 times magnitude of F2 times cos of angle between them, which is phi, right? Now in our case, this angle is 180 minus theta, right? So we could write this as square root of magnitude of F1 square plus magnitude of F2 square minus 2 times product of F1 and F2 times cos of 180 minus theta degrees, because theta is the angle between them. And when you make a parallelogram or a triangle, in both cases, the angle formed is 180 minus theta. Now, this gives you F1 square plus F2 square minus 2 times F1 times F2 times. Now what is this? Cos 180 minus theta is minus cos theta. So that minus and this makes it positive, and so what we get is this, which is magnitude of F1 square plus magnitude of F2 square plus 2 times F1 F2 cos theta. So does it make sense? So that is how you can prove it. So have a good look at it. So whenever you are adding two vectors, an angle is given between them, that is tail to tail angle. In that case, the sign changes and you can use that angle, or you do 180 minus the angle and use. So I hope this step is absolutely clear. We're almost at the end now. Treat this question as your test question. The question here is, find the difference of two unit vectors with an angle of 150 degrees. It really means that, let's sketch it here. We have one vector like this. Let's say vector A. The other one makes an angle of 150 degrees. So let's say the other one is kind of like this, making an angle of 150 degrees. So angle between them is 150 degrees. Let's call this as vector A, and we'll call this as vector B. You need to find difference of two vectors. That means you have to find what is A minus B equal to. So the steps should be, we know that is B, so minus B will be in the opposite direction, right? So that becomes minus B. Is it okay? So we have to find A minus B, so that will be our drawing. We could place this vector with tail on the head. So if you do that, you get that as your vector. And so the resultant is starting from your initial point to the end point. So that becomes A minus B. Is it okay? That becomes A minus B. And you will notice in this particular case that the angle, which is this angle, is 150 degrees. Right? So whenever you do A minus B, then applying cosine law, you have to use the same angle. So you can say that vector A minus B, let's find the magnitude first. So when we do this absolute value, we are finding magnitude, so which is equal to, unit vector means magnitude is 1, so we write 1 square plus 1 square minus 2 times 1 times 1 times cos of angle 150 degrees. Square root. Perfect. Let's calculate this answer. It is square root of 1 plus 1 minus 2 cos of 150 degrees is equal to 1.931, right? So we get this as equal to 1.931. So the magnitude of the resultant is, you can approximate this to, let us say, 1.9 units. Now whenever we say vector, we have to find a difference of two vectors. So we have the magnitude, we have to find direction also. So we could give direction of this vector with respect to A. Let's say that is the direction alpha. To find this direction, we'll apply sine law. So we can say sine of alpha over the side length is 1 unit, 1 equals to sine of 150 degrees over the side A minus B, which is 1.931. That will give us better answer, right? So we can say alpha is equals to sine inverse of sine 150 degrees divided by 1.931. So let's find the inside term first, which is sine 150 divided by 1.931, and then we'll do sine inverse of this. Sine inverse of our answer is equal to 15 degrees, right? So now we can write down the answer as difference, that is vector A minus vector B, is 1.9 at an angle of 15 degrees from A, correct? As shown in the diagram. Does it make sense? So that is how you should be actually writing the answer. So it is very important to understand that if we have specified the difference between two vectors, you have to give both magnitude and its direction, Direction could have been given with any of the two vectors given to you. So with this we come to an end of our 1.2 vector addition, subtraction, and we have actually followed a geometric approach to answer most of our questions here. We'll take up the algebraic approach in the next section, and we'll also consider scalar multiple of vector. Well, that brings us to the end of our 1.2 vector addition review. We adopted geometric approach to solve questions. Sine law and cosine law helps to find the magnitude and direction as we have seen in these examples. Feel free to write your comments, share your views, and if you like and subscribe, that'd be great. Thank you and all the best.